Today we're going to be installing this 50 amp 240 volt receptacle. This is going to be going in a garage, so commonly you would use this type of receptacle for an electric car charger, but the same principles are going to go for a welding plug, a larger 50 amp range, even larger dryers, electric dryers. So stay tuned and let's go over how we do it. Here you can see is the panel. And basically the plan is we're going to put this receptacle somewhere in this area underneath because it's in the garage, it's going to be easy to access, and we're not going to need that much material. So this is a good video to show you how you can do the same thing at home. To start off, you're definitely going to need obviously this receptacle. This is a Nema 14-50R. Now, something to note, there are different qualities of these receptacles. So Leviton makes a nice affordable one. You know, it's pretty decent, but if you're going to go for specifically an electric car charger, I recommend the Hubble brand one. It's much, I guess, sturdier, but I mean, wiring is the exact same thing. Also, you're going to need this 6 gauge. Now, this is 6 gauge Romex, and you can see there's 3 conductors, and then there's also a copper ground, bare copper ground. I just have a coil of it because I don't need that much. You're gonna need a box. Now, this actually specifies on the paperwork that you cannot put it in a single gang box. We're going with a metal double gang box. Because it's metal, you're gonna need a ground screw, bonding jumper. You need a faceplate. Different types of straps so you can secure the wire down. You may or may not need wire nuts depending on if the wire's already there. Onto the tools. Always go with a nice, some sort of multimeter. I really like the Fluke brand. This is their tester. I use it in all my videos. You're going to need a non-contact voltage tester as well. Various different types of hand tools. You know, these are diagonal cutters. Probably a good idea to have linesman's pliers because this is thicker gauge wire, wire strippers, you know, other types of pliers, screwdrivers. And I have these. These are my hot gloves because I have to show you how to wire it up. So I can't de-energize the panel because it makes the room very dark. However, you are going to turn off the power first. We're back here at the panel. Now, for you at home, unless you have the PPE and you know what you're doing, always turn off the power. It's the safest thing you can do when working on electricity. So, also, with that being said, you should probably know what is attached to your panel. So if you have critical infrastructure that you cannot power off, hold off on this project. But if you know everything in your house can be shut off, you can go ahead and identify your main circuit breaker and you can flip it into the off position. So go ahead at this time and do that. However, because I can't do that, I'm using these plugged in lights. I need to have it well lit for you, the viewer at home. I'm going to put on my Cat 2 PPE and then remove this cover. Simply, all you're going to do is remove the screws, but you'll see me, I'll be suited up, and we'll go from there. Here you can see I've taken off that panel cover, but everything is still hot. In your situation, you are going to turn off the power. But because, like I mentioned, the lights are powered, they're plugged in, what I'm going to do is I'm putting on my Cat 2 gear. So I have Category 2 rated pants. These are basically, if there's an arc flash, it's not going to melt to my skin. Same thing with this upper layer. I'm putting on a Cat 2 balaclava. Basically, this is protect my face in case something were to short out in here. So it's going to look a little goofy. But it's for safety reasons. You put it on. Put my glasses on. I should have a hood that comes down, but that's a little much for this situation. And then also, I have my gloves. I can work in here safely. Again, you, the viewer, are going to turn off the power by turning off that main circuit breaker. So I'm going to put my gloves on. It's a little cumbersome. And then we're going to check for voltage. This is what you would do. after you turned off that main breaker, you would check for voltage. All you do is take your meter, okay? You're going to turn on to voltage, AC. I have a dual function one. See, it has a V and a squiggly line. And what you would do, take the leads. See if I can turn the light on for you guys. All you're going to do is you can see there's bussing, right? That's this metal, exposed metal. There's your phases coming in. There's two of them, or your two hots coming in. So from one phase to ground, you would check. So see how it says 115 right now? Well, that means it's energized. If you turn the breaker off and you test this one phase to ground, you should have 0 volts AC. If you don't, make sure you turn off that breaker. Now we'll check the other phase to ground. Again, we have 115. It should be around 120 because right now it's energized. Again, if this main breaker is shut off, well, you're going to have 0 volts. And then you can also go phase to phase. You should have about 240. I have 231 in this case. That means it's still energized. So if I can't put my fingers anywhere inside of here. So always double check. You can also use your non-contact voltage tester. You heard it beep, turns on. Rubbing on my clothing, we know it works. And then what you would do is you would touch the bussing. If it beeps, that means it's energized. Touching the other phase, it's energized, right? But we know this because the breaker's on. But in your case, you'd want it to not beep. And then test it again on clothing, make sure we can get to work. We know it works. All right. So now let's proceed with the project. You can see that in order to attach this Romex, I have to put on this Romex strap. You can see there's pre-punched holes, or these pre-perforated holes in and around your panel. This is very common. All you have to do is you have to identify a spot where you're going to punch that hole out. So I'm going to go right here in the corner because I want my box going right here. Okay? Now, something important to note. Yes, in my case, I still have hot bussing, right? Meaning it's still energized. But identify where your service entrance cable comes in. So mine comes in through the bottom. So even if I had turned this breaker off, this cable is still hot, still energized. So if you're going to punch this knockout using a tool, be very cautious. You don't want to nick these hots, all right? You could electrocute yourself, you could cause a spark. So now that we have identified this hole, all I'm going to do is I'm going to punch it out. Doesn't take very much effort. And I'm just using my pliers. Again, I'm watching that service entrance cable. In your situation, yes, your breaker's off, but that's still hot, so you have to be cautious. Unless it's a new build, which is ideal for everybody, right? So just toss it out. And then this guy's going to go right there in the hole. You can see it's just going to clamp on my Romex. It's got a little lock ring that goes on it. I'm going to push it tight, as tight as I can, watching that screwdriver tip. And something you'll notice, see how this is orange and it even says VDE? That means it's insulated. I mean, I can use this on live circuits and the handle is going to get energized. So that's why I always like these insulated tools for electrical work. So I'm just going to remove my gloves and then I'm going to install my box down here just with some screws. I'm just installing my box down here. That's a convenient spot for me. Let's go a little bit further down. Right there is good. Now I just have to watch out for that service entrance cable because see how it goes through? You have to make sure you're not going to hit any wires or cables on the other side, but I can tell that there's no cables behind there, so I'm good. There, that guy's not going anywhere. I'm going to go in this top hole, so I'm just going to use my screwdriver. Watch this, right? It's hot. They just snap like that. Just put in this other guy. And just tighten it up just like that guy up there. Now is a good time to estimate how much we're gonna need. I like to keep about 6 to 8 inches of working wire hanging out. And our 50 amp breaker, which is what we're gonna use to go to this 50 amp, mind you, double pole breaker, is gonna go right there. So I don't actually need much wire. Give yourself a good amount of bending space. So that much. So I'll cut myself a length about like this. You can either use, you know, your wire cutters if they're big enough, or you can use your lines and pliers. So we'll just cut that. What I'm going to do right now is I'm going to go ahead and pre-strip this Romex before it's in here, just because everything's awkward in there. So if my breaker is going right here, I don't actually need that much exposed, but I want enough so I can route it nice. I'm gonna need enough to be able to reach my neutral and ground bar. So yeah, I'd say probably about this much. And if you're using a razor blade, be very careful. Obviously they're sharp, but my bigger concern is not you cutting yourself. It's actually cutting the conductors underneath, right? So you don't want to degrade the insulation of the conductors. So just carefully score along. Don't cut too deep. It's better to be safe than sorry. Sometimes it can help to get like your pliers. Get in there and peel it. You can see, here's the strip conductors. Bare copper ground, the white neutral, black hot, red hot. So what's gonna happen, mind you, make sure you have your main circuit breaker turned off, is your neutral and your ground are gonna come up and they're gonna land to the neutral ground bus bar. If in your situation you don't have your ground and your neutral, meaning your greens, or your bare copper and your white on one bar, like let's say you have your greens over here and your whites over there, make sure you put your whites over there and your greens over there, because these two may not be bonded, meaning they're not, maybe not physically attached. You can see how there's that strap up here, physically attaches those two. This is my main panel, so these two are connected physically together. Then what you're going to do is you'll take your 50 amp circuit breaker, it's in the off position, and you'll see it's got these two bolt-on like lugs. You'll take one hot, put it in the top, so either your black or your red, and then you'll take the other hot and you'll put it in the bottom. And then from there you'll keep it in the off position, route the wire out, and land it into here. You can see I've gone ahead and stripped my hots. I've actually already landed my neutral and my ground to that bar. And they just go down here. Because I have such a short distance, it's within 12 inches of box, it's secured, we're good. I don't actually have to drive in any staples. However, if you were going a further distance, you're going to have to put a staple every 4.5 feet to just secure this. You can use staples, or you can use straps or cable ties. Just make sure whatever you're using is rated. So these guys, all they're gonna do, so they're gonna go right behind here on this breaker. And then you see how this breaker has this like little tooth here? That engages with this plastic piece back here, and then you can just push the breaker on. Now that we've gone from our panel to this box, all I have to do is strip the wire, then we can wire up the receptacle. Now I'm at a point where I'm gonna be stripping back this cable. Same principle as before, just score it, okay? You don't need to plunge too deep into this cable. There we go. So that just comes off. We'll take the little cardboard piece off of the bare copper. Now, if you have a metal box, which I recommend for any Nema style plug, you know, Nema, because it's this heavier duty plug, I'm gonna recommend metal boxes. And they have this little ground screw spot in the upper portion of it. What you're gonna do is you're gonna take your ground you're going to actually end up wrapping it around the ground screw clockwise, so that when you tighten it clockwise, it actually tightens around. Righty tighty. Remember that, folks. So here's our wires stripped. As you can see, there's the copper, bare copper ground. It's looped clockwise around so that when I tighten the screw, it actually tightens along the bare copper. Bare copper is going to go to our green ground screw. Then we have our white neutral, which is going to go to our silver colored screw. We have a red hot, which is going to go to one of the two brass colored screws. And then we have a black hot, which is also going to go to a brass colored screw, one of the two. I'm gonna go ahead and start with my neutral. Usually I like to start with ground, but it's a little bit shorter because we bonded it already to the case. So we'll go to our neutral, stick it in on that silver colored screw, tighten her down as best as we can. Okay. Take a hot, I'm using my black, and I'll take, mind you, these are stiff because they're so heavy duty of a cable, or a heavy duty wire. So take a black and go to a brass colored screw, it doesn't matter which one, but it has to be a black, or go to a brass, you know, one of your hots. Your other hot, you'll take that, you'll go to your other brass colored screw, push it in. Not going to hurt the cable. Yes, they're stiff, but you're not going to hurt it. You can use some force. Tighten it down. Last, but obviously not least, you're going to attach your ground to your green colored screw and tighten it up. At this point, we've landed all our wires. All you got to do now is wrap it with electrical tape. Go over those screws. You want to cover these screws because you don't want anything slipping behind and possibly connecting. And use that Super 88 stuff. It's way better than, you know, Harbor Freight brand. And then just shove it in the box. So these wires are ready to go in. Every faceplate's different, but this one, the receptacle actually mounts to this faceplate, and then the faceplate mounts to the box. Now line up the holes and screw this guy in. And we're good to go. This just shoves in and we screw it in. There she is, nice and tightened up here, nice and tightened up here. You can see Romex goes right to the panel. Let's go ahead and turn our 50 amp breaker on. It didn't trip, that's always a good sign. Now we just gotta test it for voltage. Now that we are ready to test it for voltage, make sure that we have wired it right. Just simply go ahead, get your tester out, voltage AC, put your leads in. This is your ground, which by the way, this whole box is grounded. So I might do that, might be easier. Use the box which is grounded. 115, roughly 120 volts, right? I've mentioned before in other videos that the incoming voltage is already low because the windings on the outside transformer aren't totally correct. So we have 120 here, roughly. Should have roughly 120 here. Then here's my neutral, so I should have roughly 120. Yep. Phase to phase, should have 240, roughly. Yep, there we go. And then left phase to neutral, we should have 120. There we go, we wired it correctly. I hope you've enjoyed watching this video. It does take me quite a bit of time to get ready and to get the funds to actually purchase the materials for this, so make sure you leave a like, comment, and subscribe. I always appreciate it. Also check out some of my other videos, and I show you lots of DIY home improvement projects and especially electrical stuff. This is going to be a great way to save money if you're trying to do this on your own. You don't have to hire an electrician, but always work safely. Make sure you're confident and competent in what you're doing. And I hope this series provides a little insight on what it's like to do actual electrical work. As always, thanks for watching, and I'll see you next time.